All right, up next, this team, also advised by Dr. Compare, will use the heating fluid powered by the solar trough to desalinate water using solar thermal energy. Please welcome the solar water desalination and purification team.
How's everybody doing? My name is Derek Ganter. I'm a mechanical engineering student studying thermofluids option.
My name is Daniel Laszlo. I'm a mechanical engineer studying the mechanical option.
And my name is Eric Heusler, also mechanical engineer, also studying mechanical option.
And we are the solar-powered distillation and desalination unit. As everybody knows, nearly 70% of the Earth is water. Less than 1% of that water is actually drinkable. With our system, we plan on changing that. We had a few purposes for this project. The first was to produce a continuous, clean drinking supply from non-potable sources such as gray water, brackish water, or salt water. We also wanted to utilize a renewable energy source. We'll be utilizing the solar energy source. We do have several goals. Of course, we want to process that gray water into drinking water by utilizing the solar energy supplied by the solar trough group as discussed earlier, and also develop this as cost effective as possible, utilizing very low-tech parts to be able to be utilized in a third world country.
All right, here we have an exploded view of our entire assembly. There are three main sub-assemblies comprising our system. Our first one would be our heat exchanger, shown there with a coil. It's basically made up of a large steel cylinder tank. On the inside of the tank, we have copper coil tubing, approximately 50 feet of it, wrapped along the inside. On the outside, we have a macro filter along with some plumbing welded to it, and we have 3 pieces of angle iron welded to the outside, also acting as our support for the entire system. Our second subassembly is our bottom unit, and that is just a large square steel plate with a steel inner cylinder tank welded to it. The purpose of the inner cylinder is to reduce the volume of water inside of the system, thus increasing the thermal efficiency. And lastly, we have our third subassembly, which is our upper unit, and that is a large steel dome with some plumbing and our microfilter. All of the internal components were coated in a potable grade epoxy, except for the copper tubing, and all 3 subassemblies were bolted together for easy disassembly and maintenance.
Now I'm going to explain how the basic system works. The first thing that happens is the water enters the macro filter, which Eric explained, and that the purpose of the macro filter is to filter out all the big stuff that could possibly harm the tank, that could chip the potable water epoxy, and or even possibly destroy the copper tubing inside. Then, as the solar trough team sends us the hot working fluid, it heats up the copper tubing, which in turn also heats up the water. The water will reach a boil and will come out the top of the tank. Find the button. Yeah, you guys know where the top is. Will come out the top of the tank as steam and then condense back into water, and it goes through a series of piping to help condense, and then finally into our macro filter or microfilter, which is comprised of coconut husk and carbon coconut and sand. The coconut husk is just normal compressed coconut husk, which is a known filter for many different applications, and then the
Carbon.
Yeah, the carbon. That's the word. Sorry. The carbon coconut is basically made from the coconut husk itself, and then it is burned and then compressed itself, and then everything is put inside the filter, and as it filters through, it filters out any impurities that were still left in the water. And this will basically allow us to make any water in the world a drinkable water source.